Hello, everybody. Welcome to another SAT Math Question of the Day with Professor Emeritus Seth Chaiken from University of Albany and his brother Joel Chaiken, where we try to help you understand how to do and how to approach SAT problems. So, here we have one. I don't know if you've been watching every single one of these things, but if you have, you've noticed we've not done geometry yet. So this is our first geometry problem. The ACT has more geometry than the SAT. So if you that's one difference between the ACT and the SAT. So this is a geometry problem. The XY plane, you have line L parallel to line K. What's the value of P?
Okay, let me take a shot at it.
Go ahead, Seth.
Okay, so a line L is, see the little L is this line. Line K is this line. And the data of the problem says that the line L, this line, and line K are parallel. And then, let's see, what's the problem? The other information about the lines is given by coordinates of all the coordinates of 4 points except for P. So the question is, what is the value of P? Well, this is a pure geometry problem. Line L and line K are parallel implies that these two triangles, this one and this one, are similar triangles. Okay? And that means corresponding lengths of sides are proportional. Well, the skinny angle is the angle opposite the segment from the origin to this point. And similarly, the skinny angle is opposite the segment from the origin going down. Well, look at the coordinates. The length of this line is the length of the side from here to here is 2. The length of the side from going downward is from 0, 0 to -4. The length is 4. And so, lo and behold, the big triangle is twice the length of the small triangle. Well, they tell you how much the distance from 0 to, from the origin to -5, 0 is. That is 5. Therefore, the distance from here to here is 2 times 5, because all of the all of the lengths of corresponding edges are proportional. The factor of proportionality is 2. Well, this tells you what the x-coordinate of the x-intercept is. It is the coordinate that gives you 2 times 5, which is 10, in the x value. And therefore, P equals 10.
Wow.
And that's one of the answers.
I am so impressed. So I have one question, and then I'll do it another way. I have one question, one comment, great. And I'll do it another way. First of all, how much did you see that the first time? How long did it take you to notice that? Did you look at this problem before?
I saw the problem. I saw the problem a couple of days ago, and it took me maybe about 10 seconds to see that.
Wow, that's really impressive. That's really impressive. It's so funny. This year I helped a person in geometry, and she came in with a coordinate geometry problem. And I did it through coordinate geometry. It took about 15 minutes to do the problem, right? Oh. And it was a messy coordinate geometry problem. Then I looked at it later, and I said, oh, my God, you can do similar triangles? And I did it in 15 seconds.
Yeah. So you shouldn't characterize this as a coordinate geometry problem.
I'm not. I'm telling you a story. I'm telling you a story. I'm telling you a story about...
So it was... the thing is, the students would be wise to to look at what the information tells them about the problem, and based on that, decide whether to think of it as a coordinate problem or a geometry problem whose answer will be expressed by a coordinate.
Right. Also, my lesson that I learned after I helped this person is I realized that similar triangles are extremely powerful. And I've also come up with a little thing I say to geometry kids. Like if you're in trouble in a geometry problem, like you don't know what to do, you're totally lost, look for similar triangles or look for similar figures. Because in geometry problems that look really hard, similar figures is very often involved. So that's really
now a nice thing about the SAT is that graphs, that in other words, charts of data and geometry figures are always drawn to scale with the correct angles. And so you can glean information or clues about the data of the problem by looking at the diagram.
I mean, sometimes they draw things and they say not to scale. They do.
Oh, so you have to watch out for that.
Yeah.
Okay.
Now,
well, this problem, they did not say it's not to scale,
right.
And the fact is, it is to scale.
Right. I am not sure how many people in taking the SAT would have done it your way. Your way is really, really smart. But you also have to know that similar triangles, you have the two angles have to be the same, and you have to sort of realize that the two angles are the same because the lines are parallel. I'm not sure how many kids are going to do it that way. That's certainly not the way. That's certainly not the way.
Basic.
I know.
Yeah, there's a basic. Property in a traversal of parallel lines at the opposite, which is exactly what you have here.
I know, but I don't
know. This is the parallel line, and that's the traversal.
I know, but I don't know how many people are going to see that because
they learned it in geometry.
Yeah, but they also learned, more importantly, that slopes are equal. Parallel lines suggest equal slopes. That's stressed a lot more in geometry than similar triangles. You certainly get more practice with the idea that parallel lines have the same slope. So
it's wise. We study for the SAT to put into your memory that a problem like this demonstrates the helpfulness of knowing parallel means the lines have the same slope.
Well, of course.
It's one and the same concept.
Of course. So I think most people, like including me, and I'm channeling many kids, I don't know. And boy, it'd be really interesting. Leave your comments as to how you did this. Did you do this the super clever way with Seth? Or are you going to do it the more traditional way, like the way that most people would see it? So let me show you how you do it the other way.
Well, just correct myself that when math is developed in greater generality, parallelness and slope equality are not the same. But for the curriculum of the SAT, you might as well assume that they're the same.
Yeah, but
because the geometry they cover.
Cares. When you're in 11th grade, you don't care less about formal mathematics. I hate to insult you. Son has a PhD in math. He cares about formal mathematics. When you're 11th grade, you don't even know what formal mathematics is.
The curriculum of the SAT is Euclidean geometry.
Fine, whatever you want to call it.
And in Euclidean geometry, equal slope and parallel mean the same thing.
Okay, so let's get to how it's done using equal slope. You need to, as Seth said, if you see parallel lines, you immediately say the slopes are equal. So it's helpful to figure out what the slope of that line is, and that'll help you get P. So the slope of this line is a positive 2/5 because it's rise over run. They make it easy, right? Which means that you're going to go, what does the slope mean? Slope means that you go up 2 over 5, right? That's what it means, up 2 over 5. So let's play the game here. We're going to go up 2 to this. This is be negative 2. We go to 5. Now we're going to go up 2. We go to 5. We go 5 more. We get to 10. And the answer is 10.
Oh, great. Wow.
Okay. Fine.
That's amazing.
What do you mean amazing? How's that amazing? How's that amazing?
To realize that the coordinate on the middle of the long diagonal is 5.
Yeah, I mean, the other way to do it is if you have
Yeah,
the
that's
slope.
really cool.
You're kidding. Really? You
No,
think that's cool? I don't know. I mean, that's
yeah,
that's a natural way of doing it. It's
you
interesting,
step
right?
up.
We had both different, completely different ways to do this.
You just step up.
Yeah, you step up. Yeah, just march
Yeah,
along. It's very intuitive, but it requires you
yeah,
to remember that slopes are equal. But it also
yeah.
requires you to really understand what slope means, which is what the
Hmm.
SAT is into. The SAT is really asking you what do you really understand the concepts, and you really have to understand what slope means here. And once you understand what slope means, it's not that bad. In Seth's case, you really have to understand similar triangles. And then
Hmm.
once you realize the triangles are similar, then you could do it the way Seth did it too. So this is just 2 ways to do it. There are probably many more ways to do it. This is good. So this is great. We came with 2 different ways of doing it, and I
Yeah.
was impressed by you. And you were impressed by me.
Your method came up with the answer really quick.
Yeah, yeah.
Yeah.
The other way to do it, if you want to do it that fast, is that if it's a 2/5
Hmm.
slope, and you're going up 4, you have a total change of y of 4. Then this is a 4, this is an x. And then you said you do 2x is, am I doing this wrong? 2x is 20, x is
Yeah,
equal to 10.
that's good.
So you could
Good.
have done it that way also. There are a lot of ways to do this. So this is good. We came up with 2 completely different ways of doing it. I was very impressed by the way Seth did it, but it requires you to recognize those triangles are similar. And wow, Seth was actually impressed by the way I did it, which I thought was probably the standard way. I think most people are going to do it the way I did it. But very good. Very good. I guess that's it, right?
Yeah,
Yeah,
that's it.
that's it. Well,
So another day.
have a great day. Please
Have
leave
a
us
great day.
comments.
Yeah.
Like us, dislike us, but more importantly, leave us comments so that we can make constructive changes to this, or you can even make destructive comments. We need comments so that we know how to modify this to make this better for everyone. Okay, have a great day. Bye.